Hey everyone, welcome to a brand new Unreal Engine 5 VR tutorial. In this tutorial, we're going to cover how you can test your VR game in flat screen mode, effectively switching your character to first-person controls based on whether or not the player controller detects a VR headset or not. Now, the reason why you might want to do this, and the reason why I do this myself, is that sometimes when I'm testing certain things in my game, it can be quite time-consuming and cumbersome to constantly have to put on and remove my VR headset when I'm testing certain things that don't even require me to wear a headset or to use the VR controllers. Now, a good example of this is something I'm working on currently, where I'm just testing my enemy AI sense stimuli. And since I don't need to use VR controls for this, it's much easier to simply launch my game in first-person mode and do my testing. And if it's when I'm finished my testing, just simply exit out of the game and go back straight to coding without needing to worry about putting on or removing my headset constantly. So that's what we're going to be working on today. So if you enjoy this video, please be sure to like and subscribe for more Unreal Engine and Unreal Engine VR content. And now let's get into the lesson. Now I'm going to make the project files for this project downloadable for free, so you can, if you'd like to go through the code that we work on today, you're welcome to do so. Just click the link in the description below and you can download the project files for free. So what I'm going to do now, I'm just going to create a brand new project. I'm going to be using the latest version of Unreal 5, 5.4.3. Launch that, and we're going to create a brand new VR template. So I'll select games and then virtual reality, and I'll save this. I'll call this, what do I call this? VR flat screen testing. That'll do. And then create. And here we are in a brand new VR game template, okay? Now what I'm gonna do is I'm gonna show you how I would implement this system myself in a project I'm actually working on. So in order to do that, it needs to be usable in a project that can get quite large and complex. So to do that, I'm going to make use of certain things that, depending on your level of experience, you may not have come across before. So I'll do my best to give a brief explanation of various classes or objects I use without getting sidetracked from the main lesson, which is how to test your VR game in flat screen mode. But don't worry, even if you are a beginner, this tutorial is perfectly fine for beginner level. So the first thing I'm going to do, I'm just going to create a new folder here, and I'll call this, I'll call it _game, and any new content I introduce, I'll just put in this folder here in case you're looking for it in the download file. And then we'll go in here and I'll create a new folder, call this blueprints. And again, we'll go in here and create a new folder again, and I'll call this core. Now core is the name I give to the core, what I consider to be the core blueprint classes of a game. So that might include your player controller, might include your game mode, the game instance, things like that. Okay, so it will go inside here, and the first thing we're going to do is we're going to create a game instance class. So we'll create the game instance first, and then I'll explain what it is. So we'll right click in the content drawer and then click on blueprint class, and then click the drop down if it's not dropped down already, and then in the search just type in game instance, and you want to click on this one here, game instance, then click select, and we'll call this BP_VR game instance, and we'll double click that to open it. Okay, so the game instance. So what is a game instance? A game instance in Unreal Engine is an object that persists through the entire runtime of the game. So from the moment the game is launched from your desktop, the game instance becomes initialized, and that object then persists throughout all gameplay and remains active until the player exits the game. So because the game instance persists throughout the entire game, and because it can be accessed from anywhere, it's the ideal place to manage game-wide data, such as save files and systems that should remain consistent. Now, in our use case, we're just going to use it to store a single variable for this lesson, but this information is good to know if there's game-wide information that you want to manage. And the variable that we're going to create, we're just going to go over here and click on the plus next to variables, and it's going to be of type Boolean. And here we're going to call it allow development code ? Okay, and the default is going to be set to false. Now, for the initial event, game instance doesn't have a begin play. We have instead init. So if you go over here where it says functions and then click on this override drop down and then click on init, it'll create this event init, which means event initialize. So this event is called the moment the game instance becomes initialized. So this event will fire, but pretty much before everything else in your game, before any characters, before any levels, before any other code really, any other blueprint class anyway. This will fire before all of that. And what we're going to do here is we're just going to drag off this allow development code and then drop it right on this pin to create a set node, and we're going to tick the button, the allow development code to true. Okay, so what are we doing here now? This is more relevant for games that will only be VR exclusive games that you might be working on. So in other words, it's not meant to have a flat screen mode. It's just meant to be a VR game. So what we're going to be doing is we're going to be creating some code that will only work if we're in development. So what this will mean is that when you eventually package the game, all you have to do is come into your game instance, deactivate this Boolean, and then before packaging your game. Okay. So we'll just comment this. So we'll say so we'll say set to false before packaging game. And I'll just change the color to a nice black. I use the color black for comments on development code. So now that we've created this Boolean, we need a way to access the value of this Boolean from other places in our game. Okay, so the way we're going to use that is we're going to use a blueprint interface. So we're going to go back to our blueprints folder and right click, create a new folder and call this interfaces. Double click on that and then right click and then blueprint, and then we're going to select blueprint interface and we'll call this BPI for blueprint interface underscore game instance. Now, blueprint interfaces, they're basically a way of communicating between different blueprint classes that don't require casting or anything like that. It's a good practice way to manage communication between blueprints without relying on hard references or casting, which can cause blueprint classes to become quite coupled to each other. I'm not going to go too much further into blueprint interfaces for now, but if we double click on this blueprint interface, the only thing that you can do in the blueprint interfaces is create and name functions. You can't actually create the code for them. I'm just going to select the function we have here, press the F2 key to rename it, and I'm going to call this get allow development code, enter. Compile and save, and then we'll go back to our game instance class that we created. We'll go up to the class settings here, and then under here where it says implemented interfaces, not inherited interfaces, this one that says implemented interfaces, we'll click the add key, and then we'll search for this BPI game instance that we created and select that. Compile and save, and now we've got under interfaces here, we've got the get allow development code. And one thing I forgot actually is we'll go back to the interface here and select the function, and we actually need an output for this of type Boolean. So we'll click on the plus arrow here. It's created a Boolean variable, and we'll call this dev code allowed ? Compile and save. And you'll notice that it's turned into a different color now because it's no longer an event, it's considered a function. So what we'll do is we'll double click this, and this will take us inside the function where we can actually implement our code. And all we need to do here is just drag off our Boolean variable again and drop it on this input pin, and then click on compile and save. Okay. So now whenever this interface function is called from anywhere else in our game, it will get the current value of this Boolean, whether or not it's been set to true or false. And then if it's been set to true, then we'll set up some code to allow the development code to execute. Now the next thing that we're going to create is a player controller class. So this will go in the core folder. So we'll double click on that. We'll right click, select blueprint class, and then we'll select player controller, and we'll call this BP VR controller. Enter. Okay, and we'll double click on that, and we will go to our event graph. So what is the player controller class? Well, essentially, this is where you would put all the code that would control your character or pawn. In my opinion, the player controller class seems to be quite underutilized from what I've seen in online tutorials and the Epic Games content itself. More often than not, so for example, if I go to the VR Pawn here, so it's in VR template, blueprints, and then VR Pawn, most commonly in Epic Games content, what you'll see is that the controls for the character are put into the actual character class or the pawn class itself. In my opinion, this is a bit of a lazy way of doing things. It's not necessarily bad if this is the only character class that you're going to be using. But in my opinion, because games, as you develop them, they can get quite complex. If you put all of your controls into the character class, it can lead to a bit of code bloat. It's not necessarily bad, but it can be really difficult to manage. And just to give you an example, actually, I'll show you the code from the player controller class that I'm using in my game. And as you can see here, these are the controls and the functions and the variables that control my character so far. And as you can see, there's quite a lot of code here, and there's quite a lot of functions, quite a lot of variables here as well. Now you can imagine that this can get really, really bloated and confusing if all of this code was also in the character class. So it's best practice, in my opinion, to keep your controls in a separate class to the actual character. I'm going to be doing a video that's more focused on the player controller, but for now, that's just a brief explanation. So coming back to the BP VR controller class that we created, what we're going to be doing in this class is going to detect whether or not the player is using a VR headset. If the player is using a VR headset, it's going to execute the normal VR controls. If it detects that the player is not wearing a headset, it's going to instead execute the regular first-person shooter format of controls. Okay, so I'll just delete this tick because we won't be needing that. And the first thing that we're going to do here is we're going to right-click, and we're going to use a function that's called is head-mounted display enabled. Just get that one. And we'll drag off the Boolean value there and type in branch and connect that to begin play. So on begin play, it's going to detect whether or not a head-mounted display is enabled. Now, if true, what we're going to do is we're going to add the enhanced input mapping contexts for VR controls. Now, at the moment, these are in the VR Pawn. So we'll open up the VR Pawn, and if you aren't sure where that is, it is in, we'll go back to the main folder here, it is in VR template, blueprints, and then here VR Pawn. Okay, so you'll see in our VR Pawn here what it's doing is it's getting the player controller, and then getting access to the enhanced input local player subsystem. And then from there, it's adding the mapping context for the VR controls, so the IMC underscore default and the IMC hand controls as well. We're going to be doing this in the player controller instead. So if the head mounted display is enabled, what we're going to do is we're going to right click, and because this is already of type player controller, we don't need to get the player controller. We can just type in get enhanced input local player subsystem, and you'll click on this one here. And then we'll drag off there and type add mapping context. And we want to get the IMC underscore default. So you can click on this magnifying glass to find that in the content drawer. And while it's highlighted, go back to your controller class and then click this arrow to assign it. And then we'll do that again. So drag off add mapping context. And this time we'll get the IMC underscore hands. So in the content drawer, it's this one here, and just click on the arrow to assign it. And then we'll hook this up to the true value. So if the head mounted display is enabled is true, then we will add the VR control. Now, if the head mounted display is not enabled, what we want to do is we want to add the mapping contexts for first person shooter template instead. So what I'm going to do is I'm going to go down to the content drawer and I'm going to click this add button here. I'm going to click on add feature or content pack, and I'm going to have first person template selected, and I'm going to click add to project. And this is going to add the content from the first person project template to this project as well. Just give that a second. Okay, that's done. Now we can close this, and I'll close this as well. Go back to our player controller. Now if we go back to content, and let's see, so this should be under first person, blueprints, no, sorry, input. And we've got another mapping context here called IMC default. We just to distinguish this one from the other one, I'm going to rename this to IMC underscore FPS. We're not going to worry about the weapons one. But if we double click on this, you'll see the mappings associated here. So we've got input action move, input action look, and input action jump. Okay. Now, before we can actually implement this, there's something that we need to change about the VR pawn that we're using. Because at the moment, this is of type pawn, which you can see up here in the parent class. But in order to use the, In order to use the jump functionality, the jump function is actually of type character, which is a specialized type of pawn. You will need to change the parent class from pawn to character. And this will also give you the ability to set up smooth locomotion as well, because of the character movement component that gets added. But what we're going to do is we're just going to go to class settings here. And then here where it says parent class, we're going to click the drop down here. And then instead of pawn, we're going to type in character. And we want to select this one here, okay? And then this is now of type character, as you can see here. So I'm going to close this. And if we drag this out, you'll also notice that it's added a character movement component. So if you wanted to implement smooth locomotion, you can now do that with this as well. Okay, now back to the main lesson. What we're going to do here is we're going to get, I'm just going to copy this node, so Control C, Control V, and we're going to drag off that add mapping context. And this time we are going to assign the IMC underscore FPS. I'll just click on that arrow to assign it there, and then connect that up to false. Now that's not the only thing that we want to do. We also want to make sure that when we add the FPS controls, we also remove the VR controls. Okay, so what I'm going to do is I'm going to drag off this again, and I'm going to type in remove, and we want to remove mapping context. Hook that up. And for this one, it's going to be IMC underscore default. And again, we're going to drag off another one and type remove mapping context, hook that up. And this one is going to be IMC hands. Okay. And we also want to, if we're not going to be using the FPS controls, we want to remove that as well. So if up here, we'll drag off this one and type in remove mapping context, and hook that up like so. And then we'll click the drop down here, IMC underscore FPS. Okay, so now that that's done, what I'm going to do is I'm actually going to highlight all of these nodes, and I'm going to right click and then type in and then select collapse to function. Drag this over here, and I'm going to call this function, just highlight it there, press F2 to rename, and then type in set mapping contexts. Compile and save. So on begin play, it's going to assign the mapping context based on whether or not the headset is detected. So now that we've done that, what we will do now is we'll just go back to our VR Pawn and we'll highlight all of this because we don't want double handling on our code. Just going to delete all of that. Now what I would normally do as well is I would take all of these controls that are currently in the character class and I would refactor them into the player controller class. I'm not going to do that for this tutorial because it would be a bit of a tangent to the main lesson. So we're just going to leave that here. But what we will do is we will implement the first person player controllers here in the player controller, because at the moment, if the headset's not detected, it will add the mapping contexts for first-person shooter template, but the actual input actions won't get executed because they haven't been implemented anywhere in our code. Okay, so what we're going to do is we're actually just going to copy them over from the first person pawn. So we'll go back to the content folder and in first person and then blueprints. And it is this one here, BP first person character. Double click on that. And all our controls are quite straightforward here. We've got the camera input, the movement input, left, right, forward, backwards, and the jump input. We're going to highlight all of this, Control C to copy, and then back in our controller class, just get some space here and Control V. Now, when we compile, we are going to get some errors, and I'll explain those in a minute and show you how to fix them. We hit compile, and you'll now see a bunch of errors showing up. Now, why are these errors showing up? The reason is because these functions, you'll see here it says target is pawn. That means that these functions are functions of the class pawn. Now, this blueprint class is not a class pawn. This is a player controller pawn. One way that you can fix this is to simply right click and get controlled pawn. Now this is a function of the player controller, and you can hook that up to target like so, and then compile, and you can see that error has gone. But what we're going to do instead, because our character is actually of type character, we would run into a bit of a problem when it comes to the jump functions, because as I mentioned earlier, the jump functions, as you can see here, it says target is character. Now you can't simply hook up the get controlled pawn function. You can't simply connect this up to a character input, because as you can see here, it says pawn object reference is not compatible with character object reference. So even though a character is a type of pawn, it's not going to recognize this input. So what we need to do instead, and what we'll do here as well, I'll just delete that as well. We'll go back up here to the event begin play. And what we'll do here is we'll right click and type in get controlled pawn, and we're going to cast this to character. Now this class is the base C++ character class. There are no real drawbacks to casting to this type of class, so don't worry about using the cast in this instance. It's not really a problem in this case. And what we're going to do here is we're going to drag off the as character and click the promote to variable, and we're going to call this controlled character, enter. So now we've got a reference to the controlled character. So what we're going to do is we're going to drag this off and then get controlled character and then hook it up to target. And we'll do that for all of these. You can actually just drop it directly onto the pin. And if we compile, you'll see that those errors go away. We'll do the same for down here. For movement input, drag off controlled character, drop it on the pin. And again, and then for our jump functions, drop it on the pin and drop it on the pin, and we'll just fix these up, compile, and now all of our errors are gone. Okay, so now we have the controls ready to go. There's a couple things that we need to do before we implement this. We need to, first of all, we'll go to our edit up here and select project settings. And we need to click on this option here, maps and modes. And we'll drop this drop down arrow. Now you'll see that the default game mode, the player controller class, is just the base player controller class. We want to change this from player controller to BP VR controller that we created. So we'll click on that, and it's one of the options here. Just select that. So now when the game launches, it will be using our custom VR controller instead. And the other thing that we need to do is we need to go down here where it says game instance, a game instance class. At the moment, it's just using the base game instance class. We want to use the one that we created. So we'll select BP VR game instance and then close that. So now what we'll do is we want to make sure that this only works in development only. And not when we actually package the game. So if we go into our set mapping contexts function, if we right click here and type in get game instance, we can get game instance. If we drag off this pin here and type in get allow development code, this will bring up the message for the function that we created in our blueprint interface. Now, personally, when I'm just getting the value of a Boolean, I prefer using pure functions rather than functions that have to be plugged in via code. Now, as far as I'm aware, you can't do that with blueprint interfaces. So I'll show you a little trick to implement this a different way. So what I'm going to do is I'm going to go to our content drawer, go back to content, our underscore game folder, and then our blueprints folder. And then I'm going to create a new folder here, and I'm going to call this BPFL for blueprint function libraries. And then I'm going to go in here and I'm going to right click, and then under blueprint, I'm going to select blueprint function library. And you can see the description here. It says blueprint function libraries are containers of functions to be used in other blueprints. They cannot contain variables, inherit from other blueprints, or be placed in levels. So basically what a blueprint function library is, it's a list of functions that you can use in any blueprint class across your project. And normally when you're creating a function, you have to create it within the blueprint class itself, and then you can only use that function within that particular blueprint class. But a blueprint function library gives us the ability to create functions that can be used in any blueprint class essentially. I'm just going to rename this to BPFL underscore I'll just call it global functions for simplicity. I'll double click that. And what I'm going to do is I'm going to create a function with the same name as the other function we created. So I'll call it get allow development code, enter. And what I'm going to do here is I'm going to right click and get game instance, and then drag off the return value here and get our blueprint interface message. So I'll type in get allow development code, and you'll notice that it's under BPI game instance and it says message in brackets there. And I'm going to hook that up like so, and then I'm going to drag off the execution pin here and type in return for a return node, and then hook up the Boolean value here. And then lastly, what I'm going to do is with the return value selected, I'm going to click pure. So this is now a pure function that calls this message. So if I go back to our BP VR controller, I'll delete this and right click get allow development code. We now have two different options here. One is the message that we used before, and the other one is a new one here, get allow development code, and this is now a pure function. So we can just drag off this, add a branch, and then hook this up like so out of the true pin. And you can now call this function from anywhere in your project. And this is the reason why I set the value, set the Boolean value for allow development code in our game instance. Because if you want to implement development code anywhere else in your project, you can now get this function to help facilitate whether or not the development code is allowed. And then when you're ready to package your game, you can go to your game instance, deactivate that tick, and then when you package the game, it'll make sure that development code is no longer allowed, and this code will not be able to be utilized in a packaged game. So now if we go to our level and we click the play button, you'll notice that the controls aren't working the way that you'd expect. That's fine, we'll fix that in a moment. But the move controls are working. If you hit the space bar, the character will jump. And it's now working essentially the way we want it to. We just need to fix up that the look input action. So we'll exit out of play, and all we need to do is we just need to go to our VR pawn, and then off begin play here, you'll notice that this blueprint is already utilizing the is head mounted display enabled. So what we're going to do is we're going to come off of false, and we're going to right click and type in get allow development code, and we'll get the BPFL global function that we created, and then off that get a branch. And if development code is allowed, we'll hook that up there. And then what we're going to do here is we're going to select our camera in the components window, drag that off, drop it onto the event graph, and then drag off here and type in set use pawn control rotation. Hook that up to true, and then set this Boolean value to true. And then we're also going to right click and type in set use controller rotation. And it's this one here, set use controller rotation yaw, and hook that up like so, and then click that as enabled. Okay, so if head mounted display is not detected, it will change the way that the control rotation is utilized so long as development code is enabled. So now if we compile, save, and then go back to our template and click play, and now the look control is behaving exactly the way that we would expect it. And you can see that the camera is clipping through the hands that are just sort of stationary there at the moment, but that's fine. And this is essentially how you can test your VR game in flat screen mode. I know that we covered quite a few other things in this tutorial as well, which means that the tutorial was probably a little bit longer than it would have been if we just covered the control side of things. But I thought that it was important to go through the way that I personally utilize this system in a project, because the way that I've utilized it here makes it scalable across a very complex project, particularly if you want very different controls, or you want the game to behave in a very different way if you're operating the game in flat screen mode. So if you need to, for instance, get the allow development code function from anywhere else in your project, you've now got that ability to do so. You've got the VR controller here that sets the appropriate mapping contexts and has the first person controls here. So we have covered quite a lot in this tutorial, and I hope it was useful. I hope you got a lot out of it. And yeah, if you liked the video, as I mentioned, please be sure to like and subscribe, and I will see you next time.